Welcome to Old Man Does
Shaders
Extreme Edition. Today we're going to speedrun this Franken shader conversion based on Martijn Steinrunken's Heartfelt shader on shader toy. We're just doing the raindrop effect part that you see here, so let's get stuck into it. Now, in an ideal world where I knew what I was doing, you would write this in an unlit shader directly by modifying the libraries to make it a lit shader. In fact, Martijn has a tutorial to write this raindrop shader for URP, and without being lit. He uses a grab pass to grab the color buffer, but one does not simply grab the pass in HDRP. You first have to capture the pass using a pyramid, sample it, and take it out to dinner. I failed at importing the HDRP libraries, so in the meantime, here's a method that uses shader graph and HLSL. Now, the first thing you'll want to do is go to our GitHub repo and download the project files. Thanks for watching. For everyone else, open or create an HDRP project. Make it look pretty and create a quad. This will be our window. Create an HDRP lit shader graph. Right click and make a material from it, then add it to the quad. Next, we need to create the HLSL file by opening the working directory, creating a text file, then changing the extension to HLSL. Open it up in Unity, then head over to Shader Toy and steal Martijn's Heartfelt shader code. Through the power of hindsight and editing, I realised it would be easier to make all the changes in the shader code first, then make the shader graph in Unity instead of jumping backwards and forwards between the two. So delete the crap at the top but leave the licensing info because that stuff is important. Next, add an if and def clause. These are... I don't know what these are for, but it's better to have them and not need them than need them and not have them. So type if and def followed by the name of your HLSL file, then redefine your file name just below it. Scroll to the bottom and close off the if and def. Back at the top, delete the has heart and use post-processing defines and take out the cheap normals line. Now we need to change all the HLGL syntax to HLSL syntax by finding and replacing all of the variables on the left side of this list with those on the right side. So go ahead and find and replace each of those. Take out the float3 declaration in the N13 function because HLSL doesn't let you define a single valued float3. You can also delete the N14 function. We won't be needing it. Since Unity doesn't use an image buffer like Shader Toy, I like to change the main fragment function to frag4. No matter what you call it, make sure you type _float afterwards or Unity won't recognize it for our custom function in Shader Graph. We have to change all the parameters in our frag function. Starting with the inputs, we want a float4 _UV parems and another float4 parameter that we can pass all our shader graph properties into. The frag4 custom function will output two variables, a float2 UV and a float level of detail which we'll call LOD. Remove the first three lines of UV declarations and the has heart block. Now punch out the following variables. Float2 UVP, which is just caching the surface UV of the quad we'll be applying the material to in Unity. Float2 size is the size of the quad that makes up the size of our window, UV parems Z and W. Float blur for the amount of blur on the window, set to parems X. A float trail blur to adjust the strength of the blur of the droplet trails. Float zoom set to parems Z. A float rain amount set to parems W. Rain amount doesn't really work that well in this conversion, but if you are interested in a more in-depth tutorial, then send me money. Change time to just _timey. Visual Studio sometimes flags this as an undeclared variable, but it can't speak HLSL, so just ignore it. And lastly but not leastly, define a float2 UV variable set to UVP times size minus size times 0. This line of code automatically tiles the raindrop effect based on the scale of the object it's applied to. At least that's what my grandma told me. Delete rain amount since we declared it above, leave min and max blur but take out the story and heart. And delete everything in the has heart block up to the else statement. Delete the end if and zoom declaration since we defined it above as well. I've commented out this UV line for now because it has some role to play later down the track. Take out cheap normals since we don't care about frame rates in our games, and delete the next has heart block. I've gone with a crappier focus calculation mostly because I couldn't make this one work, so go ahead and delete it. Delete the post-processing block since all our post-processing is handled by the HDR pipeline in Unity anyway. Get rid of the dirty color reference and clean things up a bit. This line handles the droplet trail blur And just below that we handle the surface blur of the glass, which we are now calling focus for some reason. Also delete this other colour reference that was staring you in the face this whole time and define our UV output as n.x and n.y. Lastly, send Martin's beautiful code off to ShaderGraph by setting the outputs. Save it and head to ShaderGraph. Alrighty, we're almost done. So start by creating an HD scene color node and connect it to the base color thingy. This is more or less the grab pass for HDRP and ShaderGraph. Create a screen position node and a custom function node. We'll be adding the UV out of the custom function node to the screen position UV, then feeding that into the scene color UV input. Create two vector 4 blocks that will form the UV parems and parems inputs for the HLSL frag4 function. For the material tiling and droplets, we need to access the quad's surface UV, so create a tiling and offset node, split it and connect it to the X and Y of the vector 4 block. You could change the parameters of the HLSL frag4 function to 2 float 2s for the UV and tiling inputs, but you have to split the object scale. Create an object node, grab the scale output, split it, take the RGs and connect them to the ZW shinbone respectively. Now we punch out all the float parems for the material. So create a blur, trail blur, zoom and rain amount float properties and hook them up to the second vec4 parem block in the exact order you see here. On the custom function node, in the source field, find your HLSL file and in the name field type the name of your fragment function sans the underscore float. So in my case that's just frag4. Because I'm a big dumbhead, the def at the top of the thing should be defined, so go ahead and change that if you haven't already. Shave it and then head back to ShaderGraph. If you didn't change mix to lerp, do that now as well. Alrighty, we're almost done. We just need to set the inputs and outputs on the custom function node, so set vector2 out for the UV and a float out for the LOD.
I said float.
Connect the UV out to the add node and the LOD out to the scene color LOD. Set and name the two vector 4 inputs and hook the two vector 4 blocks up to them. Make sure exposure is ticked on the scene color node, change the LOD output back to float because you just never listen, and now you should see tiny dots on the custom function node. To make them large dots, set a default value of 1 for rain amount. Save it and head to your scene. Make sure the material is set to transparent, and Bob's your uncle. This should be enough to get you started on modifying Martin's Raindrop shader in HDRP. If something has gone wrong, there's always the code on the repo if you get stuck or if I've missed something here. Thanks for watching.